Good afternoon, everyone. It is my pleasure to welcome you all to the third day of our online faculty development program on applications of mathematical techniques in agriculture, science, and technology. Our first distinguished research person has already joined us, Dr. Shubhra Katara, ma'am.
Hello.
Ma'am, are you with us here? Can you hear us?
Yeah, sure, I am here. Can you hear me?
Ma'am, you are not audible to us.
Okay, but hello. Hello.
Hello?
Hello. Hello.
Yes, ma'am.
Yeah, I am on voice. I'm unmuted.
Yes, ma'am. Ma'am, I'll just take a moment to introduce you to our participants.
Yeah,
with due
sure.
respect.
Yes.
Ma'am is a professor in Head Department of Statistics, Bareilly College, Mahatma Jyotibai Phule Rohilkhand University, Bareilly. Welcome you all to the third day of our online faculty development. Dr. Katara has more than 35 years of teaching and research experience. She has published over 25 research articles. Her areas of interest include applications of statistical methods in various fields such as medical sciences, agriculture, genetics, and several others. Today, she will be delivering her talk on the topic, some statistical methods for experimental sciences. Over to you, ma'am.
Yeah, hello. Welcome you all. Good afternoon.
Good afternoon, ma'am.
Yeah, there is some echo also, no? So there is some voices are coming from the background also. Is it okay? Am I audible to you?
Yes, ma'am, you are audible to us. I'll be sharing your PPT with us as you requested.
Yes. How many students, participants are here? Hello. Hello.
Good afternoon, ma'am.
Good afternoon. Hello.
Yes, ma'am.
Just a second.
Okay.
Ma'am, we have 43 participants here.
Okay.
Hello.
Hello. Hello.
Yes, ma'am, you are audible to us. Ma'am, please continue. Ma'am, you have muted yourself. Can you please unmute yourself? Okay.
Hello, everyone. Hello.
Yes, ma'am, you are audible to us.
Yes.
Please continue, ma'am.
Yes. So today we are going to discuss some statistical methods. Statistics, as you all know, is a subject which is applicable to most of the subject, and especially when we go for some research, for some experiments, then definitely for analysis purpose to come over some certain conclusions, we need to apply some statistical methods. That is, we have some numerical data with us. Whenever we have some numerical data, and in today's time, it is imperative that you should go for any experiment which can provide you some insight into the form of numerical data. So, my topic is some statistical methods for experimental sciences. Well, these methods are applicable for humanities as well. But the term is that when we go for some experiment, it becomes scientific thing. When we go for some experimental thing, when we collect some data, and when we put it into some form which is comparable with other data of the similar kind, and with some or more things are there which can be proceeded for further research, it all becomes a scientific process. Scientific process is something where we analyze things and compare with the original things, with already known things. So my topic is some statistical methods for experimental sciences. Next slide, please. Are my slides coming?
Yes, ma'am. Are they visible to you? We are on the second slide right now.
Yeah, right. Yeah. So here you can see some bars, some bar diagrams are here. It is just a representation that this is what we think about statistics, how we are going to interpret it, how we are going to proceed with these figures. These figures can be related to any experiment for anybody's view. So statistics actually provides to make these figures and then analyzing such things. This is a very general concept of statistics, that we go for some collection of data and then we put it into some graphical form. So this is a raw form of presentation. Here I have not taken any particular data, but it is a general figure that how a statistical thing is started. Whenever we have some data, we have some categories, we have some frequencies, we have some variables, we have some parameters. I think most of the experimenters are acquainted with these words, with these terminologies. Next slide, please. Yeah. Why statistics? Why we should go for statistical methods when we have already so many subjects here? So, as I say, that when we go for some experiment, we have to analyze our findings in some numerical form, and then these numerical form lead to actual results. If we go for a collection of numbers only, if we get some data and we don't analyze it and we don't present it, we don't inference, we don't draw some inference from it, then this all this collection of numbers is just like bulk of numbers, bulk of raw things, which cannot be lead to any conclusion, which cannot take you to any conclusion. A collection of numbers is just like a herd of cows. It doesn't know what is its purpose and where it will lead the research. Numbers cannot tell you anything unless you go for putting these numbers in some other form. Let me show it to you by an example. Next slide, please. So here are some figures about some any data. It's just a example where I have this data is just an hypothetical data. It represents, for example, it represents some number of engineering colleges in these cities. Like Kolkata, there are 60 colleges. Siliguri, there are 10 colleges. In Delhi, there are some 65 colleges. It is just a example and not an effect. So this represents number of engineering colleges in these cities. Definitely, this is not a very attractive representation of data. Definitely, we cannot conclude, we cannot even remember what it is going to Kolkata 60, Siliguri 10. You cannot remember all these numbers and you cannot compare which cities. You have to go again and again to see the data and then find out where there are maximum number of colleges. And overall, what is the comparison of these figures? We cannot figure out just if we have raw data in this form. So an experimenter can collect data, but to put it in some figurative form, to put it in some estimable form, to put it in some conclusion form, we have to apply some more statistics. Statistics in general, it's a term associated with the data. Statistics means when you have some estimation in your mind when you want to uh, go for some experiment and there is a very huge set of data, and then you have to concise it to make it eligible for understanding to you and others as well. If you want to show your research to someone, then you have to go for some analysis of it. When we go for theory, we teach like just like we are going to teach in UG classes, then we go to very basic things like there is this data, there is frequency, then we go for central tendency, then we go for variance. Definitely, these are the basic statistical methods, and you cannot move forward without these methods. But once you have crossed that threshold, once you have crossed that PG threshold, and now you are coming for some experiments while during your PhD or while during any other project or while going for any scientific experiment, then you must know what are the statistical strategies. So today, I'm not going to discuss the mathematics behind the statistical strategies because that is a very complicated thing and it cannot be understood just by means of slides. If you want to understand mathematics, then definitely you have to go deeper. But today, I want to give you an insight that what is the statistical process, how we go for any experiment, and how what are the major methods for applying in statistics. You must understand that statistics is a tool, but you have to be a good worker to use this tool. You can have a brush in your hand, but everybody cannot paint the same thing. Just like it, statistics is a tool, but everyone will use it according to his or her own capacity. So, for understanding statistics, you must understand that we are going to draw some data from some population, now from some experiment, from some already existing data, which is called primary data. So, all these things you must be having in your mind. Next slide. Now, the same data is transformed into a pie chart. Now it sounds much better. Now it is much better representation where you can see that I have put a title. It's very simple representation. It's very simple data and just starting of statistical uses. This representation makes some better sense to the eye of the viewer. And to anybody which is not directly related to the study can also understand that, okay, this is the thing. If we can put the names in these triangles, then it will be more eligible also. But it's okay. We have given some indicators for which shade is for Mumbai, Chennai, Bengaluru, Delhi, Patna, Lucknow, like all that. So I think you can agree with me that this representation is a better representation. Anybody wants to say anything? Next slide. Hello? Yes. So statistics is a crucial foundation for all experimenters, providing the tools to understand, to analyze, to interpret data more effectively. It encompasses both descriptive and inferential statistics, enabling scientists to summarize data, identify patterns, make predictions, and test hypotheses. Basically, statistics is a subject which is used, which is used as a whole, as a group of many methods, and not any one method cannot describe that we are using statistics. Next slide. I've given just some review all for all of you that all of you must be familiar with some of the terms. What are major statistical concepts? these concepts are used as a whole in any method. You cannot go for any one thing if you use statistics. And that's why it is important that you understand the basic, what is the purpose of data, why it is being collected, what is the size of the data, from which sources it is coming, and how much reliability you can put to these data. And
Hello.
Hello,
Sorry about the glitches, ma'am.
no issue.
We are back, ma'am. We are on the slide, role of statistics in experimental sciences. Is the same?
Am I audible? Because your voice is very low from on my side.
Ma'am, yes, you are audible.
Okay. So we are here, role of statistics in experimental sciences. Once again, I am just going through it, repeating the things I have already told, that statistics is crucial foundation for all experimenters, providing the tools to understand, analyze, and interpret data effectively. It encompasses both descriptive and inferential statistics. It enables the scientists to summarize data, identify patterns in the data. For all these patterns can be used for the future modeling and to make predictions and test hypotheses. Okay, next slide, please. Slide 7th. So once again, I want to discuss these concepts in short. What are major statistical concepts which are used for the analysis purpose? What are the major things which one experimenter must use, must know, must learn before going for any experiment? Because once you have started the experiment, you cannot move back. So if there are any shortcomings, that should be removed at the start of the experiment only. And for that, you must understand that from where your data is coming, what type of data you are going to use, whether it is variable form, whether you have parametric, whether you are going for non-parametric studies, whether you are using primary data or secondary data, whether you are going to use sampling methods, whether you are going to use some design. Mainly agriculture scientists use design of experiment, analysis of variance. Most of the psychological studies, most of the medical studies use sampling and of course design as well. So major key statistical concepts are: number one, first and paramount, descriptive statistics, which enables us to summarize and describes the characteristic of a data set using simple measures, which sound simple but which are very effective measures, like mean, median, mode, range, variance, standard deviation, correlation, regression, then fitting of the curves and distributions, probability distributions. These things all come in the category of descriptive statistics. Second term, very important, that is inferential statistics, where we draw conclusions, we test hypotheses, we go for some models, and there we set some critical regions, we set some error, and on that basis, we decide which method of testing we are going to use, which is called inferential statistics. Inferential statistics is one of the toughest part of the statistics, because once you are done with your experiment, you cannot move back, as I already said. So you have to apply testing on the basis of the original data, from which source you have collected it. It all matters. If the population you are considering is large, then testing methods will be different, and so on and so forth. Another important concept in this, you must all I know that everyone who is at this level is familiar with certain statistical terms. Some persons are living. Astha Dubey, who is she? Probability, and then hypothesis testing, then regression analysis. All these terms are very familiar to all. And all these things require a lot of study to understand what is the topic is about. A very important point in any statistical analysis is sampling. Sampling means you are going to collect a set of data to represent a larger population, and you are extracting a small part of the population for your study. So you have to be very careful from where you are taking the sample. So that sample should be taken in such manner that it represents the whole population effectively. And for that, we apply some methods. We have some sampling technique. We have some probability sampling, we have non-probability sampling, and all these require different type of calculations. Another thing which we usually use at the very start of the any statistical process, at the start of any experiment, and which can be done very quickly, is the data visualization. You can very quickly analyze something to get some inference about it by just making some graphs like economists do, like time series analysis. You go for a graph and you can see the trend. You can see the trend of how prices are moving. And for that, you can just, you have 100 years data, you have 2 centuries data, and that can be like weather also. We can go for some graphs, etc., and that will represent the trend of the, say, rainfall, say heat, say temperature rise. All these studies where we use terms, it's whether it is global warming, whether it is sea level rise, all these things, from where these are coming? These all things are coming from set of data. So this time series data, that can also be put to some graph type or some curve type. So data visualization is the key to get into larger insights. Before going for actual modeling, we put all these data into a rough form, which is first form. Next slide. How to proceed for statistical analysis? As I already said, that when we go for coursework like BSc, we go for teaching basic principles at first. First, we go for data collection first. Then we tell our students that how we will make some tally marks, frequency distribution. But when you are going for an experiment, as we are discussing the topic here for experimenters, for researchers. So process of any experimental projects starts with designing, which is definitely not a first thing to be taught in the class. Designing is taught after many lectures. The process of any experimental project starts with designing, planning, and ascertaining what is actually required for execution. It is to ascertain that all parameters, variables, factors are taken into consideration. You have to decide beforehand that what are your variables will be, what will be your variables, which variable is in the form of continuous, which variable is in the form of discrete. There are some continuous variables, there are some discrete variables, and both type of variables need different methods to analyze them. So you have to ascertain that all parameters, like you are going for some experiment, and if any parameter is left, you cannot put it again once your experiment is over. So you have to ascertain all these things beforehand. For an experimenter, it is important that he or she should have insight into some statistical methods as well, so that data is available for all required fields when your experiment is over. So what you have to do actually, you have to discuss your experiment with your mentors, with the guide if you have, or if you are going it all by yourself, then go for a good review of literature, what others are doing, what other your contemporary researchers are doing, whether they are successful in applying some method, or whether they are in just middle of the analysis and they cannot decide. So statistical analysis, you must know that the population you are using is of the nature where your methods can be applied. I think you are getting my point. Next slide. Next slide, please. Statistical thinking. You know, need not to be a statistician for having a systematic thinking. And statistical thinking is just synonym with systematic thinking. When you go for statistics, yes, this slide, please. When you go for applying some statistics, please stay here. I'm going for it. So you must understand that doubts are often better than overconfidence. So before going for some methodology, for deciding about some methodology, you must put all your doubts on paper, and then you should head towards the experiment. Definitely, experiment will be as per your subject, but the method with which you will proceed in it may be a mathematical one, may be statistical one. Research will be yours, but the layout will be of a statistician. The data source should be well defined, and it is important that all secondary data is taken in from reliable sources. One must be clear about proper execution of experiment, that what factors you are taking. Will you be able to measure all these things in the set time? One must be clear about proper execution of experiment so that there are no missing figures. It must be clear in the start of the experiment whether the data set, population, and samples are going to be large or small. You must note that there are different methods for large samples and different methods for small samples. Large samples most of the time tends towards normality, and small samples, they need different other methods. Like a small sample may exhibit some chi-square distribution, a small sample may exhibit some t distribution, some geometric distribution. When we go for large samples, most of the populations converge towards normality, but that's not the case with the small samples. Sometimes you have samples like size of 5, 7, then all the methods which are quite known to us becomes irrelevant, and then you have to go for some very specific methods. So a good research involves the selection of the sample before thinking about the experiment itself. If you are clear that your experiment is going to cost you very much, then definitely you will go for small samples. And when you will be going for small samples, then the methods will be different from the methods which will be used for large samples. So for statistical application for any experiment, you must be clear whether the data set, population, and samples are large or small. This is the first thing. If your analysis needs a large sample, then if you are going to apply some test which needs a large sample, then you must decide your sample size beforehand. Because when you deviate from the basic assumptions of any theory, then you will be losing the efficiency. You can draw conclusions, no doubt about it. Data doesn't know what method you are applying on it, but you are knowing that you are doing it correctly or not. So if you want good results, then you must apply theory to the core. Secondly, one more thing which we almost omit, that randomness. Randomness is very important for any test procedure. Most of the tests are based on randomness. And if you are going to pick and choose things, then that's not a random process. Random process means you must accept whatever is coming to you. If you are leaving some portion of the data, then definitely you won't get the desired results. Or you will get results which you want, but that will not be actual results. As they say, figures don't lie. Figures are always true. Liars figure. So we must be clear that we are going to put our maximum efforts into making the data set more reliable, and we must present whatever is actual truth. Just today, I am going on some FB post where Trump asked CNN, which is very major network in US, that you must work for my image. You must show the image to the world that US is a good country or something like that is happening. Then the executive of the CNN, this chief executive replied that you do good work and we will report it. So a good reporting, a good experiment is that where actual things are shown. If actually things are going to be good, then it will be shown in figures. You cannot just mend the figures to make anything which is bad good. You have to rely on exact figures. So figures have a very crucial role in any experiment, and whatever they are saying, that should be accepted. One more thing, whether the observations will be independent, identical, uncorrelated or not. These terms should be decided beforehand. Because like I said, that major methods will take care of the independent figures differently and dependent data differently. There are separate methods for independent data. There are separate methods for identical and non-identical methods. There are separate methods for correlated data and for uncorrelated data. So you must be clear on which path you are moving. Next slide, please. Yes, now, what is the process of statistical experimentation? What is the process of analyzing any experiment with the help of statistical methods? Also, these objectives are very much clear to everybody, and these are very crucial for any method application, not only statistics. But because I am telling you about statistics, so I am using these slide for telling you what are the major steps for using statistical methods. Number one, define your objective clearly. Once you are clear with your objective, you must see what type of ground you are going to put your experiment into practice. Whether it is a field, whether it is a lab, where you will be using different machines, where you will be using different temperatures, like in biological sciences and chemistry, different concentrations. So all these things, you have to concise the vastness of your experiment. You can concise it very efficiently with the use of proper design. You don't need to go for a very huge experiment with a simple layout, with some efficient layouts. With some very efficient layouts, which are called experimental design, like you have heard the names of randomized block design, Latin square designs. You can plan your experiment beforehand, and it will give you very efficient results. Even if you are going to analyze 250 units, you can concise them to 25 units. You can make layouts which are equally efficient with less number of data, with less number of experimental units. Design of sampling surveys. Then there is data collection. Then preparation of data. These are major steps you have to follow one by one. You first have to select the experimental design on which you are working. Then you have to select whether you are going to generate data yourself, that is, you are going to use your own primary data, or you are going for secondary data. For secondary data, definitely you have to go for surveys, Then collection of data, how much time and cost it will take. You must take into consideration that. Representation of data for quick view. After getting a quick representation, you will lead towards the major other methods. You have to apply other methodology only on the basis of overview. Finding figures for the data and using a statistical inference for the findings. The last step in any statistical process is using a statistical inference, where you have to use some test, where you have to test some null hypothesis about it. Next slide. Defining objectives. So I have just tell you some titles for statistical experimentation, how we will proceed. Now I am elaborating these points. Defining objectives. For any experiment in all fields of science, arts, commerce, medicine, or agriculture, objectives are specific measurable goals that define what a research study aims to achieve. They guide the research process, ensuring focus and providing direction for data analysis and interpretation. Essentially, they answer the question, what does the experimenter hope to accomplish? Objectives should be set as per available resources. One must not set objectives which are you are unable to achieve those goals. You must not go for that. Like in a country like India, if you go for some national level research, then you have to contact so many states and union territories. You have to contact so many agencies everywhere until unless some data is available to you. So if you are going to collect data, you must understand that the vastness of the field. If you are going to collect national data, then you have to go from Jammu Kashmir to Kanyakumari and then Gujarat to Arunachal Pradesh. So you must understand that what is the vastness of your research objectives. Until unless you have a good project which involves several lakhs, you cannot go for such data collection. If you are relying on secondary data, then it is another thing. But for an experimenter which is going to collect, because all experiments are definitely not done in the world. Definitely your process will be unique to you. So you have to collect data as per your process. And that process may involve going here and there and giving some questionnaires and then collecting them back and having the errors in that and then all these things. So you must understand how much time you have in your hand, how much money you have spare for all these data collection, and how much manpower you have to send to all directions. So if you don't have that much money, then you go for different techniques which involve different methods. You can go for stratification, you can go for systematic sampling. So if you can decide the nature of your work, what type of work you are going to do, and what is the accessibility of resources to you. How much resources do you have? So statistics is actually a very practical subject. It's not a very ideal subject. It involves a lot of things in mind. What is the actual situation when you are going to put your views into some experiment, when you are going to interpret something from your experiment? You must be very factual for applying good statistics or for getting good results. It's not a experiment like you are sending some atoms into some metal and then seeing what is going on. But statistical thinking is not in your scientific experiment. Statistical thinking is applied to the layout of your experiment. So you must know what is the available resources to you, what are the objectives should be set, as I have written here, objectives should be set as per available resources like time. It's very important that your experiment should complete in defined timeline. manpower, equipment, and finances. Next slide, please. Our next objective, our next point in any statistical methodology is selecting experimental design. Choosing the right experimental design is crucial for the success of any study. It involves carefully selecting a framework that aligns with the research questions, objectives, and available resources. More often, design of experiment is related to life and agriculture experiments, and designs like factorial design, randomized block design, or Latin square designs, and different other more designs are also there, are selected on the basis of factors and their labels. How many labels are there? How many factors are there? What is the contrast? What is the original figure? What is the neutral figure? And how much time it will take to cultivate your experiment. Most of the agriculture scientists use analysis of variance, design of experiment. Because this method, experimental design, is basically developed for agriculture scientists. And later we apply it on biosciences as well. And now we can apply it on major psychological experiments as well. Then there are some experiments related with genetics where we can apply it in experimental design. Most of the economics and commerce works deals with time series and variable data. Next slide, please. Yes. As we say that experimental design is one part of the statistical experiment, but if you are going for collecting data which is already existing somewhere in the society, like we can go for some diabetes patients. So you don't have to create diabetes patients to study diabetes. You have to have a frame, population frame of any city, of any hospital, set of hospitals where patients are coming. So your focus will be on the patients. So these patients already exist. Then you have to design some survey, sample survey you have to design, because you have to select your objects from the society itself. You are not cultivating your objects. The objectives are already objects are already existing in the society. You just have to go to them and fetch some data from them. So in that case, when the studies are of this nature, where objects are already having some data with them, and we only need to report it to ourselves, to our system, we go for designing the sample surveys. A survey should be very specific. You must have some questionnaire in your mind. That questionnaire should lead to a proper data given to you, which you can apply for your analysis. There are two types of sampling methods which we generally use. One is probability sampling, and that there is non-probability sampling. Both methods are important. Probability sampling, we already decide what is the chance given to each unit for being selection. And sometimes we have to go for non-probability sampling and have to collect data on the spot. Just like in electoral polls, we don't have a proper population. We just have to be there at some time, at some place, and collect data from the voter itself for some electoral polls. But if we go for some, if we want to study some anemia patients, then we have a data set and we have some blocks in our city, we have some tehsils in our city, we have our own city districts, and we can divide the whole population into different segments, and then we go for probability sampling. But sometimes there is some on-spot surveys, and that on-spot surveys are based on non-probability sampling. So all these things actually are decided before, and any experiment will start After we will decide in which category this experiment will fall, whether it will be probability sampling or non-probability sampling. Next slide, please. It is continuation of the previous slide. Designing the sample surveys. Why is sampling important? Because it makes research possible. I am already discussing these things with you. Makes research possible when studying the entire population is not feasible, is impractical. We go for sampling. Reduces the time and resources needed for research. And it allows for faster data collection and faster analysis. So it increases the efficiency of the experimenter if we go for sampling. If we go for randomly going to collect data, then definitely that data will not be result, and it will be only a clutter sort of thing that, okay, we have this, we don't know what are the categories, we don't know what are the age groups from which. So all these things are considered before designing, before going collection of data. And the design of experiment and sampling surveys, they both contribute to the proper collection of data. Next slide, please. So we have this slide, like I ended my previous sentence with data collection. And this is the heading for the next slide. Data collection for an experiment is the process of gathering and measuring information on variables of interest. It must be in a systematic way. It must be in a way that we can answer research questions, we can test hypotheses from this, and evaluate our outcomes. What else we are doing in statistics? Definitely we are going to evaluate the outcomes. We are going to compare these outcomes with the existing data set, and sometimes with some other experimenter as well. Sometimes we have to compare data from different cities, etc. It's a crucial step in all research endeavors, from academic studies to business analysis. The methods used for data collection can vary widely, depend on the research field and the specific objectives. I think I have elaborated all these points before. Next slide, data collection part 2. Why is data collection important? It ensures accuracy and reliability. A well-executed data collection process is essential for ensuring the accuracy and reliability of research findings, and it supports informed decision-making. The data collected can be used to make informed decisions in various fields, including business, healthcare, and social sciences, commerce, economics, etc., etc. Next slide, please. Data facilitates us for hypothesis testing. Data collection allows researchers to test conclusions about the relationships between variables, provides a basis for analysis and interpretation, and collected data forms the foundation for analysis and interpretation, enabling researchers to identify patterns, trends, and insights. Yes, next slide, 18th slide, data preparation. Once again, we cannot do the even cooking in our kitchens if we have not prepared something. You cannot cooking just by going to kitchen and putting the raw vegetables in cooker just without peeling them, without cutting them. And how can we do things without preparing our data for experiment? So it's just like, yeah, I can say that any statistical experiment, any statistical methodology is something similar to cooking in the kitchen. You have to prepare beforehand before making a dish. Data preparation in research is the process of transforming raw data into a usable format for analysis. Yeah, cut the potato, cut the capsicum, and then you will go for making a sabji. And it is just like that, that you have to prepare your data in different categories. You put your data in the tabular form, in some graphical form, in a form where you can use it for mathematical analysis. Because a heap of data, just like I show you in the first, second, third slides, that a heap of data cannot lead you to better results. You have to understand that you have to put, like if there are some age groups, then divide your data according to age group. If there are some region-wise, you are going to study something, then divide your data into different regions like that. This involves cleaning, structuring, and enriching data to ensure it's accurate, consistent, and suitable for research questions. It is a critical step that significantly impacts the reliability and validity of research findings. Next slide. To understand where your data will lead, you have to make a raw chart, a scatter diagram of the data, a raw chart of the data, some graph or some curve. Data presentation in statistics refers to the way data is organized and displayed to make it understandable and easily analyzed. And in fact, also that where it is leading. If it is a downward line, if there is some upward trends, there are some static trends like that. So all these things you can go for. And representation of your data in some figurative form. This can involve using tables, graphs, or other visual representations to reveal patterns, trends, and relationships within the data. Effective data representation is crucial for drawing meaningful conclusions and making informed decisions. I think we are getting late, so I am quickly moving towards slide 24, using statistical inference for the findings, because all these things which I have already discussed in detail. So statistical inference is the last resort of any experimentation. Statistical inference is the process of using sample data to draw conclusions about a large population. It involves using statistical methods to estimate population parameters, to apply testing of hypotheses, and make predictions about the population based on information from a smaller representative sample. So statistical inference involves some major statistical concepts, which are the most important concepts while applying testing: population, sample, parameter, statistic. You must understand all these things beforehand. And second slide for statistical inference 2, slide number 26, please. Estimation is a very important part of statistical inference. And all these things are real statistics, where you use a lot of mathematics, where these methods are actually outcome of a very huge, long series of studies. And after that, these methods are established. Estimation, using sample statistics to estimate population parameter, and then hypothesis testing, and then confidence intervals. These are major points in deciding any result, drawing any conclusion from the data. Last slide, please. 27 number. Yeah, knowledge of statistics is most important asset for any experimenter. It is like having a huge amount of money in your bank where you are going to use a little of it. You can understand the importance of having money if you are going to apply it for some project. And if you are short of money, then definitely you won't know where you have to stop your project. But if you have double the amount of money you need for any project, then you are assured that we will successfully complete our project. So knowledge of statistics is most important asset for any experimenter. And being a statistician, I'm not saying it just because it is something related to my subject. But I really feel that any experimenter should be able to estimate the things beforehand and then stick to conclusions. This tool should be used very, very cautiously. So statistics is a very good uh, tool which can be used for a betterment of any experiment, and all experiments are very authentic if you use it through statistics. Thank you for your patience hearing, and I think that you must be able to understand the things.
Thank you so much, ma'am.
If
It was very
any
insightful
comment,
session.
then
Amidst
please.
all the technical glitches, you were very supportive and patient with us. Thank you so much.
No issue. These things
The floor
happen.
is now open for a brief question and answer session. If anybody has any question or want to discuss something, they can unmute themselves and ask the question directly to the resource person.
Yes.
All right, ma'am. We do not see anybody asking any questions. So
Thank you, Prerna. Thank you so much. Thank you, Dr. Prerna.
Thank you.
It's really nice to connect with you all. And I hope that this session will be at least something helpful for understanding of the subject, while most of them may be acquainted with these things also. But I hope that I am able to summarize my subject specifically for your purpose.
Definitely, ma'am. Your presentation was comprehensive and I think everybody understood it. That's the reason that we are not having any questions up. I'd like to
That's a good
formally offer you a word of thanks. On the behalf of the organizing committee, I deem it as honor to extend my heartfelt vote of thanks. I extend my heartfelt gratitude to Dr. Shubhra Katara, Professor and Head, Department of Statistics, Bareilly College, Mahatma Jyotibai Phule, Rohilkhand University, Bareilly. She has given us a deeper understanding of the subject, forcing many of us to explore the application of statistics with greater curiosity and unerring accuracy. We are truly grateful for your time and efforts, ma'am. Thank you so much.
Thank you, Prerna. Thank you, Dr. Prerna. Thank you, all students, participants. All the best to all. Thank you.
Thank you, ma'am. Thank you again.
So I'm leaving now. Bye.
Moving ahead with the event, we have our second session of the day. Dr. M.K. Sharma, have you joined us?
Hello, good evening.
Good evening, sir.
Good evening.
Yes, sir, we can.
Okay.
We welcome you here, sir. Allow me a moment to introduce you to our participants.
It's okay. Okay, sure. Thank you.
It is an honor to introduce Dr. M.K. Sharma, sir, Professor and Head, Division of Statistics and Computer Science, SCOST, Jammu and Kashmir. Dr. Sharma has completed his PhD in mathematics from SCOST, Jammu and Kashmir. With more than 25 years of teaching and research experience, he has contributed immensely to the field by publishing over 150 research articles. Today, Sir will be delivering his lecture on the topic Analysis of Variance and Analysis of Covariance and Analysis through SPSS.
Okay.
Over to you, sir.
Okay. Thank you, Dr. Prerna. If I'm right, because we are meeting you
Dr.
virtually.
Prerna is here with us, sir.
Oh, first time. So, yeah.
And she's Dr. Ridhima.
Okay, thank you. Okay, ma'am. So first of all, I would like to thank the organizers to giving me an opportunity to interact with all, in fact, with the organizer as well with the others audience. So regarding the topic, I think so they all are kept mute and they are controlled. I think so, everything.
No, sir. They can participate if they wish to. They can raise their hands and they can
Yeah.
unmute themselves at any time.
Okay.
So we are keeping the discussion session at the end, but if you want to interact in between, you are free to do that.
they can do it. They can
Yes.
do it. Okay. So I think so. First of all, good evening to all of you. This is related to the, as I have been assigned with the topic related to about the ANOVA and the ANCOVA. So I would like to start my presentation. I will directly, even though before, if you want to discuss anything, I can start directly with my presentation. Just a minute. Is presentation visible?
Yes, sir, your presentation was visible. Can you share it again?
Oh yeah, why not? But just a minute, just a minute.
Yes, sir, it is visible to us.
Yeah, it's okay. Okay. As it is discussed, I'm going to discuss a topic on the related to ANOVA and ANCOVA. So it is one of the point what is the ANOVA and what is the ANCOVA, because I think so might be some audience are some researcher, they are very well know about this, and some researcher want to understand it what were the ANOVA and ANCOVA. So basically, both are the techniques. Before going to start it, I would like to say both are the techniques. In statistics, Pratiksha, you want to talk with me, Pratiksha Sharma, because you're otherwise muted. So I would like to discuss ANOVA and ANCOVA in statistics. There are two basic terms which need to be always understand. Firstly, question arises: what is the statistics? Statistics is a science which can summarize all the sciences. You can see the word from the statistics, you can understand. Statistics word itself is very self-explanatory word. There are three S in statistics. They themselves convey statistics summarizes sciences. And second, I could say, as the modern statistician Carl Pearson said, it is the grammar of all the sciences. So you can understand the beauty of the subject of the statistics. If you are dealing with certain data related to your science, and you want to, you need to be focus on your reliability and validity of the data, you need the support of the statistics. And two terms are very important in statistics. One is the average, and second is the variance. If you understand these two words, I would like to say not words, tool of the statistics, average, and second is the variance. All this different technique, what we are talking, start from the, I could say, from exploration of the data to testing of the data to the design of the data, multivariate analysis, whatever we talk. So all these two, these two specific terms which I'm speaking, average and variance, they all techniques are on basis of average and variance. Somewhere we are dividing one variance with the other variance. Somewhere we are dividing mean with variance. Sometimes we are adding mean with the other variables. So all techniques are derived from these two specific terms. One is the mean, average, and second is the variance. And usually the question arises, what is the variance? Average, you very well understand if the performance of a certain data, if it's having different observation and you're taking average, so that is the average. But variance means the change of the observation. When observation one change from the other observation, we called it as variance. And I was speaking about the technique of ANOVA and ANCOVA. These are the basically two techniques in statistics which we are using. ANOVA, we called it as analysis of variance. Analysis of variance is a technique which split the overall variation into the variation due to the different components. I could say, just like you all are sitting here, there are within variation is moving. When I'm speaking, a variation has been started when I'm speaking. So within variation. Between variation, when I have delivered lecture and another speaker is coming, so they have a different methodology to teach it. So that is the different between variation. When we are going with the treatment, so two different treatment, they have a treatment themselves have a variation, but and treatment within variation is there. And within variation mean it is due to the extraneous factor which are beyond the control of human being. So we are talking about the internet, we are talking virtually. So I cannot control this internet connection. I cannot control my power issue and other. So these the variation. If it will creep into the lecture will be of a different way. If it won't it will go smooth. So that is between variation, within variation, and this ANOVA technique divide the overall variation into the variation due to the different respondents or components. And then I will talk about the analysis of covariance. One C is added in the ANOVA, if you understand. C matlab, I could say this C is what? This is a covariate variable. Another variable entered into the ANOVA. There is one is a Y variable and one is an X variable. We are talking about the Y with respect to X. ANOVA is helping us in terms of between variation, within variation. This C is entered within the ANOVA, so you can understand this is a covariate variable. And this is another variable entered between the Y and X. So that how to evaluate the Y in the presence of X through the another variable when it entered into the field, that is called as ANCOVA. It is a more advanced, I could say, in the breeding trials, this technique is more advanced than ANOVA. We have then RM ANOVA, repeated measure ANOVA, and we talk about MANOVA. So these are the four important techniques in statistics: ANOVA, ANCOVA, RM ANOVA, and we talk about the MANOVA. So before going to start, I could say George Bernard Shaw very beautifully explained that it is the mark of a truly intelligent person to be moved by the statistics. Why? You very well know. A lot of example, lot of case studies where you couldn't find anything. When you apply statistics, you will be able to your paper published somewhere. And due to the specific objective, it was your in hand, but you need to prove that objective. You need a support of the statistics. And then what the contents I have taken, I will talk about how ANOVA entered, what is one-way ANOVA, two-way ANOVA. Then I will talk how can be analyzed through SPSS and how ANCOVA is there and how we analyze through this. So before going to start it, flow chart, it is what is indicating what is the basically ANOVA. I am interested to discuss here. Generally, when persons, researcher or scientist come to me, my first question to him, how many groups? Because statistics, there are two parts. One is the estimation part and second is the testing part. Estimation means you're drawing the information from the sample. That is the estimation. I'm talking about the average, I'm talking about the variance, I'm talking about the skewness, I'm talking about the kurtosis, I'm talking about my CV. What is my CV? This is simple. This is estimation of a person. But you want to test the person. That means you are drawing the inferences related to the population. When you work on the sample, but you generalize, you are interested to generalize your result for the population, then you need the role of the testing. And ANOVA is come under the category of testing. ANOVA is further, but mine I would like to discuss here. I have to start my question with how many groups. If a researcher come, I'm dealing with only one group. I want to study this one group only. I will ask, okay, no issue. I will apply certain, it will be in my mind. I will take a diagnosis how to handle it. I said, okay, I will apply t-test. When he said I have two groups, then again question come in my mind, and in case of parametric test, then I will ask groups are independent or groups are dependent. If a researcher says that the groups are independent, or the way he will explain it, I will try to understand he is talking about the independent group. Then in case of parametric test, then I will ask, okay, I will apply t-test. If it is a non-parametric, then I will apply Mann-Whitney U test. But if the way he is explaining me about the groups, I quote that both the groups are dependent to one another, then again, it will be stuck in my mind. I have to use in case of parametric PRT test, and in case of non-parametric, I will apply Wilcoxon signed rank test. But when the researcher asks, sir, I am dealing with 3 or more groups, that means the role of all t-tests stopped here in order to compare the average performance of the one group, two groups, vice versa. But in case of more than 2 groups, that means he is talking, I have to split the variance, then I need another technique which will split the variance, and I will able to compare 3 or more groups. So I need the role of the ANOVA. So then I will come to the ANOVA. So this is my topic of today. Again, question arises. If he's talking about the 2 groups, then again, my question will be there. Is it how way he's asking? The material is homogeneous? Then if he says, yes, sir, material is homogeneous, the way he explained me, I will apply one-way ANOVA. If material is not homogeneous, heterogeneous, then I will talk about the two-way ANOVA. If I got another variable is between the y and x, then I will ask, okay, you want to understand the role of y and x in the presence of the covariate variable? Then yes, sir, I want to study this. Then I said, okay, we will see it to it, and I will immediately, it will stuck in my mind, it better to use ANCOVA. And if both the groups, y and x, they are related groups, I got it, then I will go with the repeated measure ANOVA. When I have to study many dependent variable through only one independent variable, then MANOVA is a technique. Just like we are talking y with x1, x2, x3, x4 in regression, but now I'm interested to study y1, y2, y3, y4 with the x. That means many dependent variable through the only one independent variable, then I am interested to generalize my result for the population, then MANOVA technique is powerful. So I will accordingly, I will decide on the basis of the researcher coming to me what technique I have to apply. Is it ANOVA, it is two-way ANOVA, or it is ANCOVA, or it is a repeated measure ANOVA, or MANOVA. So my topic today will be on one-way ANOVA, two-way ANOVA, and ANCOVA. I'm not going to discuss today. This is not part of my today lectures. But in future, if you are interested, then I will talk in future, or you can put in a query. I will try to answer them. So first question arises, sir, why you are talking about the ANOVA? Is it not possible? Can we use the t-test? Just like I have in a 4 treatment A, B, C, D. I should apply t-test on A or B, then apply A test on with the C. Then I compare A with D, then I compare B with C, then I compare B with D, then I compare C with D. All
Hello. Sorry for the technical glitch, participants. We'll just ask our resource person to join again. Wait for a few minutes.
Sorry. 49
Sir, you are on mute. Kindly unmute yourself.
Okay. I think so there was an issue related to internet.
That's all right, sir.
Okay. So I was talking, just a minute.
Sure, sir.
So I was talking, if I have to compare the 4 treatment at a time, A, B, C, D, should I go with the 6 t-test differently? Or we have another technique where I applied a one certain technique and I should compare all the 4 treatment at a time. Yes, I have it. And that is in statistics called as ANOVA. I can compare all the 4 treatment with a single statistical tool that is called as ANOVA. If I will apply different type of 6 t-test to compare it, it is basically not true. It is related to a certain type of error in statistics we call as type 1 error. And secondly, is it valid? No, the result cannot be valid. Maybe it look like if you apply the t-test, it will show that like B and D are statistically different from one another, and maybe in a through ANOVA they are at par. If you see B and T, there is a very small significant difference among the B and T. So what is the question? What is analysis of variance? As I told, it evaluates the different, it bifurcates the total amount of variation in the data set into 2 parts. That is the amount ascribed to chance and the amount ascribed to the specific causes. What is the reason? That means why there is an effect in Y due to the independent variable, or y, the effect in change in y due to the environmental error. Environmental. So this is called as, we called as different type of, this is ANOVA. About the ANOVA I am talking, this one. So it evaluates the difference among the means of 3 or more groups. This application can be used if I am interested to compare the average performance of the A versus average performance of B versus the average performance of C and versus the average performance of D. If I need to compare the 4 different treatment with respect to the population variance, so I need the use of the ANOVA technique to separate the variation, and after that I will apply ANOVA technique and I can compare it. Yes, there are certain assumptions. Population should be normally distributed. Population should have equal variances. Samples are randomly and independently drawn. That means if one treatment doesn't have an effect on the another treatment, so and effects are additive in nature. Here we discuss, I'm discussing about one-way ANOVA and two-way ANOVA, as I already discussed with you. When I'm talking about the one-way ANOVA, that means we are investigating the difference among different categories having many possible value. I would like to say when material is homogeneous and when material is not homogeneous, we talk about the ANOVA. Usually in agriculture experiment, when all the lab experiment like pertains to, I could say, is a lab experiment, biochemistry, biotechnology, if you are talking about the, I could say about the soil science and biochemistry, and when you, all the experiment which is performed in the lab conditions under the control environment, like medical sciences, like in animal sciences, when surgery is done, when it is all under the control environment, we talk about the one-way ANOVA, and when it is not under the control environment, it is in open field, I could say, we talk about the two-way ANOVA. So there are the 3 basic principles of the design, which when we applied in ANOVA, one is the replication. Replication means estimation of the error. That is very important. If you, just like you are hearing me first time, and when I will deliver a lecture second time, when I will deliver same lecture in third time, the knowledge of the, I could say the knowledge of the statistics or precision of your to understand will be changed. And your question will be, might be a more. That means you are estimating the error. So the replication means the repeated of the treatments when it is applied again and again and again. So that means you are able to estimate the error, how much error is there. And I could say to reduce the standard error of the treatment means if we use replication. And randomization. Randomization means allocation of the treatment to the specific unit such that every unit has an equal probability to opt that treatment. अब treatment का मतलब treatment means the condition and state which you applied into the field where you are performing experiment. So randomization means the allocation of the treatment to the experimental unit in such a way that all the treatments have equal chance of being allocated to different experimental unit. It is known as randomization. What it do? It's a very dangerous. I could say it eliminates the human biasness. If it creep into the experiment, I could say the objective of the study will be totally changed. I can show you through example in the if I through the board. I think so if possible. I will try to show you a example how it can affect. Just a minute. You can see I'm taking example of the randomization, how it is very important. Just try to understand. I'm taking it 3. I'm a statistician. I'm a biostatistician, and one company pharmaceuticals come to me, and he has a 3 type of different blood pressure medicine. It is manufactured by that company, A, B, and C. And there are different composition of the, I could say, drug they have used in there. But they are asking me question, which Manish, you have to test which is the good. These 3 products we have new manufactured, three new drugs. This has been introduced by our pharmaceutical company, whose production I should do more, which is you are feeling more effective medicine for the blood pressure patients. And being statisticians, what I did it, I moved to the persons having a BP problem. I formulated three groups. And first group, I got on a patient who having a blood pressure problem just from the 5 days. Last 5 days, they are feeling problem and they're suffering from the problem of the blood pressure. And then another group I formulated, the person, those who having a BP problem, blood pressure problem from the last 5 years, and they're suffering very much from this disease, blood pressure problem. And another group I got it, they have a hereditary problem. And they, in their family, the way the family talk, the way family live, their hereditary problem is there. And I followed that group. They have a BP problem and they doesn't take it so much important as this is a part of the disturb in the, and I could say in the lifestyle. What I did, I give this medicine to this group, and I give this medicine to this group, and I give this medicine to this group. Obviously, what will be happen finally? The result will become A medicine is the best. And I said my owner of the pharmaceutical company, so this product should be increased. Its production should be increased. It's better to take it in huge quantity rather than B and C. But how? Why? The answer is totally wrong, because the reason only reason here only why it happened. The reason is that, just a minute. The reason is that the disease which having just 5 days before they got in a medicine and they are covering very much. The disease which having a problem with the 5 years, or that's why that means we are interested to give a medicine on the basis of the which is the best medicine, but we are advising the medicine on the basis of the duration of the duration of the disease. So what I have to do it? I have to give this medicine to this group also. I have to give this medicine to this group also. I have to give this medicine to this group also. I have to give this medicine to this group also. Similarly, I have to give this C medicine to all the group also. And after that, which medicine is coming good, that I need to be say, I have to advise them, this will be a good medicine. Isn't it? I think so. Is it visible?
No, sir, it's not.
Just a minute.
So,
Okay, so I was talking about this randomization. So randomization means it will change your objective. Instead of giving the best medicine, I'm giving the medicine on the basis of the duration. So if you want to do the randomization means every treatment, every unit has an equal chance to opt that specific treatment. So local control, when there is a heterogeneity in the field, so that can be, in order to maintain the homogeneity, we divide the whole field into the different blocks such that there is a homogeneity within the block and heterogeneity among the blocks. So yes, total variation, there are one way ANOVA, there are, I told this total variation is split into variation due to the treatment and the variation due to the within the plot, within variation, or we call it as between variation. And if you go to the different books, they said sum of square between, sum of square among, sum of square explained, among group variation. Similarly, sum of square within, sum of square error, sum of square unexplained, and within there is a different name in the different book. So one is the between variation and second is called as within variation, and this is more dangerous in the sense this within variation is beyond the control of a human being, and this variation due to the treatment. So hypothesis for one way ANOVA, what is that? hypothesis, we have to what is the main hypothesis? We want to test all the different treatments having a average level. They are similar to one another, but see, they do not have the same performance. Or you can see from this graphically also, we have 3 different treatment and their average level, their performance same. This is null hypothesis. And alternative, at least the one different among the 3 different treatments. If I have taken at least one different, or maybe all the different treatments, all are different. And you can see all the hypotheses are on the basis of the population parameter. Mu is a population mean, X bar is the sample mean. Always when we use hypothesis, we should talk about we are going to estimate the population rather than the sample. We always use numeric figure of the population. And when one-way ANOVA we have a source of variation. This is summarization of the table. You will see when I will do the analysis. I will show you one performance through SPSS, how to analyze it. We will get in this type of table, sum of square, degree of freedom, mean sum of square. This is also called as variance when you divide the sum of square with respect to degree of freedom, and the ratio of these two. And always within, among the variation divided by within the variation will give you the app value, and this app value is compared with the tabulated value. And if your tabulated value is this critical value, and when your calculated value is coming more than that, it fall under the shaded area, that means you reject the null hypothesis. That means it is reject the null hypothesis. That means they do not have the same average performance. The performance of the treatment vary with respect to their average. Or similarly, when you talk about the two-way ANOVA, the sum of total variation will be split between the different groups, like factor A, factor B. I'm talking about the spacing. I'm talking about the irrigation. And even though I'm interested for their, and this is also we call as error, or sometimes we can estimate the interaction also. I will talk when this topic will come. So interaction is one. What is the basically interaction? When one factor is unable to maintain its nature in the presence of another. You can see that this factor A is here and factor B at a different level. You can see they are not interacting with one another. But here the factor B is losing its, I could say effect when the other level of the other factor is moving. So it is changed. So that means the factor A is interacted with in the presence of B. They have an interaction. Both have an interaction, factor A and factor B. So analysis using SPSS, how we can do the analysis, just like I have taken example from the book, like I am interested. These are the, I could say, to test the significance of the variation of the retail prices of a certain commodity in the 4 principal cities like Bombay, Calcutta, Delhi, and Madras. 7 shops were chosen at random, and their price are noted 1, 2, 3, 4, 5, 6, 7. So 7 shops are we have taken, and these are the 4 different I have taken cities, and their prices are noted. And it is in my mind to calculate, it is in my mind to test that maybe Bombay is more costly than Delhi, than Madras, than Calcutta, or vice versa, Calcutta having a low price as compared to the other cities. So this is the I am interested to compare the prices of the 4 cities, and I would like to discuss Delhi is a costly city or vice versa, Bombay is a costly or Madras is a cheaper. So this is my main objective. So what is the null hypothesis? Null hypothesis will be the average performance of the price of the Calcutta city average mu A equal to mu B equal to mu C and mu D. So how to feed the data, that's very important. So like I have kept it as a coding, Bombay, Calcutta, Delhi, and Madras. So 1, 1, 1, and 2, 2, 2, and 3, and this is 4. So 1, 1, and then 7 is there, and then 2, and then 3, and then 4. So you can see there, 7 times I have typed the 1, 7 times I have typed the 2, 7 times I have typed the 3, and 7 times I have typed the 4. This is related to the variable which I have to compare. So these are the price of this need to be compared, and this is my X variable. And now this is the price. This is the price it is given. It price is 82, 79, 73. So all prices have been faded here. So this is the data view. Then I will go to analyze. Then I will go to compare means. And then through compare mean, I will click on the one-way ANOVA. So what will be happen when I will click on the one-way ANOVA? I will get in a dialog box. So I will shift these both the variables will be firstly here in this input window. Then I will select price and it will put to the dependent list, and then I will shift my this another variable to the factor. Then I will go to the further. Then I will go to further. Okay. After that, then after that I will go to the next level, and according to that I'm interested to firstly, then I'm interested to compare the price of the city on the basis of the average province. Maybe the price of the Bombay and Delhi city are at par, or price of the Kolkata and Delhi are at par. I'm also interested to do it. Then what I can do it, I can use the post hoc test. If I will click on this post hoc test button, so I will be able to compare pairwise comparison of the city, or I will be able to make the group of the city, which cities are come under which groups. So I will do continue, and after doing the continue, just continue, you can see there Bombay, Calcutta, Delhi, Madras. So I got their mean, standard deviation, standard error, lower bound, upper bound. That means confidence level. That means mean lies between these two value, and minimum and maximum. And this is the my ANOVA. As I told, this is summarization of the table. You can see there between group, within group, and total, or you can see there non-significant it is coming. Or it is what indicating when non-significant is coming. That means in statistics we called as the average performance of all the cities are same. That means the price of all the cities are same. And as I told, if I applied the post hoc test, I am interested to compare Bombay with Calcutta, Bombay with Delhi, Bombay with Madras. You can see there in all the cases, it is values coming more than 0.05. So 0.05 means when it is level of significance in statistics, means 5% level of significance. So it is coming more than 0.05 in everywhere. When you are comparing Calcutta with other cities, when you are comparing Delhi with other cities, and when you are comparing with Madras with other cities through LST technique. And when I applied Duncan, which can be used for veterinary sciences also, you can see that in mine case, mine example, all come under the same class. But it can be happen when it come non-significant, it can become like Bombay and Madras, they come at par, and then I will formulate, maybe another column will be formulated, and Delhi and Calcutta have the same price. So we can compare on the basis of classes, we can compare on the basis of pairwise. So when we need interested to compare pairwise, we need LSD. When we want to compare on the basis of classes, so you can use the Duncan multiple range test. So this is the another example in case of unequal replication, because one-way ANOVA technique is, I told it is a homogeneous materials. You can see the replications are different here. Just like a college are there, 6 different college, and students' performance have been evaluated. They are getting score like this, and I'm interested to see that these 6 different colleges have the same average performance versus their average performance is different. So what I'm doing, I have fed my data the way I told you. So one, how many observation? One having 1, 2, 3, 4, 5, 6. So I will type 1 6 times, 2, I will type 5 times, I will type 3, 1, 2, 3, 4, 5, 6, 7, 8 times. So accordingly, I have fed my data. 1, 1 this times, 2, 2 this time, 3, 3 this times, and accordingly, I fed my data. And then I go to analyze, compare mean, one-way ANOVA. And then I will again the same way I will transfer y here, because this I need to be compare. This is my y variable and this is my x variable. So I can I have to test this for the performance of the different I could say the colleges. So colleges I have kept it here, and then I will do it okay or post hoc, whatever you want to do it. You see it is coming significant. That means the average performance of the students which are studying under the different 6 college, under the different 6 college, it is there is a average performance. There is a variation in the average performance. Some college having good, I could say, the way they are teaching, the way they have their methodology, they have infrastructure. The student is having more average performance as compared to the other. And even though I have applied the Duncan multiple range test, you can see there their value. Here it is coming significant. That means college 1 is compared with the 3, they are statically different. And if you are interested, you can see there here I have applied Duncan. So like this 4, 1, and 6 colleges are at par when you are compare on with this basis. So you can see there 1, 6, 5, and 2 colleges are at par. And when it compare, you want to with the 3, the 3, 2, 5, 8, 6 are coming at par, and only 4 colleges different among the all different group, or on average basis the best college are coming 89, 88, 87, 86. So that means 3, 2, 5, and 6 are the best colleges as compared to other, and the least performance is of the college number 4. So similarly, I told we can use two-way ANOVA. Two-way ANOVA is used under the condition when the material is heterogeneous, and we are interested to compare the two groups. Like here is I am interested to compare the subject at the same time. We have a different type of temperature. I'm interested to compare the temperature with respect to the subject. So I need a two-way ANOVA. How to feed the data, that is important. So this is, you can see there, I have taken two variables, first variable and second variable. So the observation like first 1, 1, 76, 1, 2, 80, 1, 3, 79, 1, 4, 90. So I have fed the data accordingly. 1, 1, you can see there 2, 2, 81. You can from here this 2 and 2, 81. 2 with 6 is 98. So you can see there same way I have fed the data. 2 with 6 is 98. When it is fed in into the data of the SPSS software, then I will go to the analyze general linear model, univariate, and then in univariate you will firstly get this dialog box. I have selected my dependent variable here. There are two factors which I need to be compared, which are the fixed factor. So I have taken into this window. Then I asked, then I will click on the model. By default, this will be, this will be selected, but you have to select this by default. By default, it will be selected. You have to just take your cursor here and tick over there, and then you select the main effect and then select T and F from input to output. And then when you will transfer here, automatically this will come type 3, and then you will move next. As you will select C, you can see that T and F both are coming here, and then you will do the continue. As you will do the continue and OK, so you will be able to get your result. So this is ANOVA. This is compared to E, temperature, and you are interested to compare the different type of, I am just recalling, there are 4 type of different temperature, and there are 8 subjects. So I can explain, there are 8 subjects and 4 temperatures. There were 4 temperature. So that means they are significant. That means temperature effect is very important in the average performance of the students, effect with the average temperature. And the different, if I have taken subject, so average performance of the student with respect to average also varying. So we are coming both significant. Accordingly, you can apply the post hoc test. I told Duncan or LST, Benfroni, whatever test you want to apply, you can apply it. Then we have a 2-factor factorial. Wherever you are interested for interaction also, you are interested, you are interested to compare the college, you are interested to compare the location, but you are at the same time, you are interested to compare the college with location. So then we can use the factorial experiment. I could say another way, I have a different type of irrigation schedule. I have a different type of fertilizer. So I am interested to compare the fertilizer, one factor. I am interested to compare the irrigation, another factor. And I am interested to compare the fertilizer with respect to irrigation. So under such condition, factorial experiment are more powerful. So we can use 2 factorial experiment. So this is the way, just I have kept the variable name. Like here, I'm going to take an example of the social sciences. So college C word defined and location L word is defined, and these are the different observation with R, and then the values are there. So I have taken C, L, R, and their specific value. Score, how much score is they have got it. The way I told you to feed the data, the way I have fed it, second location, second class, second college with third location, and their second replication having 10 value. So all that data have been fed. There are 24 observation, and even though you can hear count 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 24 observations are here. So all the 24 observation I have fed here. Okay, and then I will go to the general linear model with the univariate, and then univariate under such condition, I have transferred dependent variable. I have transferred all the independent variable. Then I move to the model. And after selecting, I told by default, it will be full factorial. You have to uncheck this full factorial and you have to check this custom. You have to click on this cursor here and then transfer C, then transfer location, then transfer R, then select this C, keeping pressing the button control, pressing the button shift, C and L select together and select it here and do just press the button this one, and then it will come C dot L, C star L, that means interaction, and do it continue. When you do the continue, you will be able to get at ANOVA. You are able to compare college, you are able to compare location, you are able to compare the interaction also. So interaction is coming non-significant, but here location, here college are coming significant. So this is the way you can speak that means the performance of the college varying, where the location is not an important and location with respect to college is coming non-significant, vice versa. If you want to take an example of the agriculture system, so fertilizer is an important factor, and I can say irrigation is not an important factor, and fertilizer and irrigation is also not coming an important factor, vice versa. And then I'm interested to, these I have discussed related to different type of NOVA with respect to one-way NOVA, two-way NOVA, and factorial experiment. Now I'm interested to discuss analysis of covariance technique. As I told, another variable introduced. It is what? It is basically a combination of ANOVA with regression. When two techniques are combined together, I mean to say you are talking about the ANOVA at the same time you are talking about the, you are also talking about the same time you are talking about the regression, and this technique is called as ANCOVA. Analysis of covariance is a statistical test related to ANOVA with both categorical and continuous independent variable. Here we have a Y, we have a X, but in X, earlier in case of ANOVA, all were categorical, but here we have a categorical as well as one is a continuous variable. Just like I mean to say what I'm speaking, I can just give you an example. See, I'm interested, this is my Y and these are the different factors. So all were categorical in nature, like 4, 4, 3, 2, 2. I have just given a category. It was not in the continuous variable. Why was the continuous? Now you will see this among these different three independent variable, one variable will be like a Y variable. So under such condition, it is called as ANCOVA. I can show an example in the coming slides. So it is a link between ANOVA and regression. A covariate is a continuous variable and that correlate with the dependent variable. There is another variable which is a covariate between the Y and X. Another variable is there. It is lying and it is making an influence on Y due to the X, but it is also a responsible variable. And we want to estimate Y through X with the controlling the effect of the covariate variable. And what are the basically hypothesis here? The group means of the treatments are equal with respect to population mean, I could say, after controlling the covariate effect, versus the group means are not equal after controlling for the covariate. So there are assumptions whenever we use the design. We use statistics, we are with the assumption. If assumption violated, then we have to go with the transformation. So these are the assumptions in case of ANCOVA also. And we, if an assumption violated or failed, then we have to move with the another way. We can go with the transformation. And I could say the dependent variable and covariate is a linear and independent of treatment. I mean to say, if you are interested to study, you are studying the dependent variable y and the covariate, they should be linear to one another and they should be independent. Covariate is fixed and measured without error. There should no any error. They are independently distributed with mean VA0 and common variance. Relationship between the dependent variable and covariate is same for the all group. Yes, this is ANOVA. When we are talking about the ANOVA, that means what is the, this is my, I could say, study variable, and this is the treatment effect. I am interested, what is the response of the treatment under the different effect. But now you can see there, when I'm talking about the ANOVA, another term is entered here. You can see this is a regression coefficient, beta xij. So treatment effect and another continuous covariate variable is also entered here. So you can see this is the difference between the ANOVA and ANCOVA, the mathematical models, statistical model. Yes, example. This example I am explaining in the coming my slide, after 2 or 3 minutes, but I can discuss this one. In an experiment to study the effect of the level of the protein in a ration of cows on milk, cows on milk production, the 3 level of proteins are A, B, and C. I am interested to compare A and B and C. The design was RBD with 6 replication. Y is the total milk yield for an experiment period, and X is the total milk yield for first 15 experimental days after calving. So I can show you an example in coming slides. We have an example how to analyze and what type of data I have it. This is the compare just to ANOVA with ANCOVA. As I told, ANOVA is a process of examining the difference among the means of multiple group. But here we are talking about the technique that remove the impact of covariate variable, undesirable variable, and then we are estimating it. Both linear and non-linear model are used. Only linear model is used. It includes categorical variable. It includes categorical as well as continuous variable. Covariate is ignored, but covariate is considered here. Attribute between group variation to treatment. It divide between group variation into treatment and covariate variation. That means we will see in the ANOVA how that the sum of square of variation due to the treatment as well as the covariate variable, we will estimate separately. And the attribute within group variation is to individual difference, and divide within group variation into individual difference and covariate variance. So what will be happen if we applied in ANCOVA? It reduced the experimental error. It used to assist the interpretation of the treatment effect. It analyzed the experimental result with missing observation. So I could say ANOVA is used to test the means of 3 or more group. But on the other hand, if you are talking about the ANCOVA, it is more advanced than ANOVA because it talks about the ANOVA as well as at the time we are talking about the regression. So this is like just example I'm taking. I could say 4 different feeds. So these are the different feeds, 1, 2, 3, and 4. It is given, feeds is given to the animal, or these are given to a calf's initial age in month X and average weekly weight gain dependent value of the calves over a period of 8 weeks are recorded. So this is the earlier age, and you have given this feed, and after the 8 weeks you have measured their weight gain, and you are interested which feed is good for the animal where he's getting more weight. So you are interested, and this is also important variable. Age is one of the important variable. Their age variation is there, so you want to estimate which is the good feed in order to see the increasing the weight of the animal on average basis. You want to recommend, but at the same time this variable age is one of the important factor. So how to analyze it? We will go to the analyze, we go to the general linear model, you will select a univariate, And after selecting urine variant, you will shift dependent variable here, and you will select average weekly after the 8 weeks. What is the weight is there? You will select this is I meant to say, sorry, this feed as a fixed factor, and after the 8 weeks, what is their weight? You will be independent variable, and initial age in month as a covariate, you will shift it here. And then you will go to the model. When you will go to the model, so just like I told, you select here, you shift here, you shift here, then you will click on the model. As you will click on the model, automatically by default it will be selected, but you have to uncheck this and you have to select custom. Then this window will be open, otherwise this window will be closed. And then you shift Y and then shift X and then do it continue, and then you will see this is you getting different type of feed, and you select this feed and then do it continue. And this is the manual. If you do this experiment manually in BD Singh book or a different Agarwal book of the related to ANCOVA, you will be, it is very cumbersome calculation if you do it manually. You have to find out the ANOVA for X separately, you need a ANOVA for Y separately, then you need a sum and product of the X, Y separately, then you have to estimate the regression, then you have to estimate the sum of square with adjustment, then degree of freedom, then you will able to calculate app value, and then you will be able to calculate these app values. And about the experiment is the different type of diet you have taken is significantly different from one another or not. Then you will be able, and then age is a significant variable or not a significant variable. Then you can estimate. If you do it, if it comes significant, you will find out the regression coefficient value, and then you will find the adjusted mean of all the different diets in the presence of the age. Age is a variable by selecting it, and then you will estimate it. But here, how to move it? It's very easy. You are here, and after that, you will directly get in a window and output window. In the output window, you can see there are different 4 diets are there, and this is the average performance of all the diets, average value of all the diets, and then we have a standard deviations, and you can see here we are getting this X, and this is the diet, and X is coming significant here because we have taken the hypothesis that it is a its hypothesis value is there is a non-significant, but there is no effect of the covariate variable, but see they have a effect on the covariate variable. Yes, variable have a effect because it's coming significant. That means the variable covariate having an effect on the diet. So that's why the body weight is increasing due to the age also. Age is also one of the important variable. And then we are also able to conclude it here, the average performance of all the different diet which we have taken for the animals, they have a significantly effect. You can select which is the best. After that, apply the DMRT and other test. So as I told, is manually, but after that, you can see there, this is the average value earlier, and after it is coming significant, you can see the dependent variable average weekly weight gain will be changed. So here you can see average weekly weight gain is changed because regression coefficient coming significant. So it changed the value. You have to talk or you have to discuss the result on the basis of this table. And I, as told, you can compare the different diet with respect to one another by using LST. You can compare which having more, and all are coming significant, like 1 and 4 are non-significant, but 1 with 2 significant, 1 with 3 significant. So you can compare pairwise the different diet, you can compare it. And I could say this is the same result. This is same ANOVA, this is result, and this is also giving the same result. And this is the related to linear, it is coming significant. So that means model is best fitted. So this is all about the ANOVA and ANCOVA, which I have been assigned to discuss with you. Now I would like to open house for the discussions. If you have any questions, we can talk on it.
Thank you so much, sir. That was very enlightening and visually comprehensive presentation that you had over here with us. The floor is now open for discussion. If anybody wants to ask any question,
Yeah,
Or
if any
something-
clarification they needed, I will try to discuss with them. Yeah, if they have it, please.
Participants, you can either unmute yourself or drop your questions in the chat box.
I think so. They have no any question.
That's probably because your presentation was already very comprehensive.
Okay.
Thank you so much, sir, for your time.
Okay.
I would like to formally have a word of thanks for you. I now take this opportunity to extend our sincere thanks on behalf of the organizing committee to Dr. M.K. Sharma, sir, Professor and Head, Division of Statistics and Computer Science, COST, Jammu and Kashmir, for his highly informative and thought-provoking lecture. His clear explanations and practical insights, especially through the practical application of variances, made the complex statistical concepts much more accessible and relevant to us. Thank you so much, sir. We are grateful for your time.
Thank you, Prerna, and thank you all the organizers giving me opportunity to interact with you all. Thank you very much. And I said that this is a nice, I could say it's great. You have started the way this conference workshop. It is good for all the researchers to understand it. You are bringing all the different statistician on a single on a window platform. So it will be in future. I think so. Those who are understanding it will be good for them. Thank you. Thank you for opportunity, and bye. Thank you.
Thank you, sir.
Okay,
Thank
bye.
you for accepting our invitation. Thank you so much, sir.
Thank you.
I would also like to thank all the participants for their active involvement throughout the event. We
Yeah.
wish to see you tomorrow.
Okay, thank you.
Yes.
Just be out for today, you can be more. Bye.
With this, we are at the end of today's proceedings. We are looking forward to having your participation in tomorrow's event. That is the fourth day of our program. Thank you, everyone. Have a good day.